Well, we now come to the discussion of conservation momentum in 2D. Now, as we have discussed that the momentum conservation is in 1D is either along the x-axis or along the y-axis. So it can be either x or y. And now we are going to apply the conservation in both the planes, both in x-axis and y-axis. And for that, we consider a particular problem which we will discuss in detail to understand the conservation of momentum in 2D. So let us say that we have a axis system like this axis system, and then we have a body of mass m here, which is moving with a velocity of small v here, and let there be another mass capital M here, which is moving here with the velocity of capital V. Say after collision, these two masses get combined and they move in a particular direction like this. So this is the picture of the combined mass, which is capital M plus small m, and they are moving with a angle with the x-axis, say for example with a velocity which is u. Now this is the scenario where we are going to apply the conservation of momentum in 2D. Now to first apply the conservation, what you need to do is to break up this velocity component first along x and then along y. So if I have the component of u along x, then I hope you all people understand that the component is u cos theta, and if I have the component of u along y, then I hope all of you understand that it is u sin theta. So this is the total construction or the total problem orientation that we need to frame before getting into the solution. Now what we are going to do, students, we are going to apply the conservation first along the x-axis and then along the y-axis. So this is our simple situation here. We are first going to apply the conservation along x-axis and then along the y-axis. Now let's see what comes out if we do what we are saying here. So here what we are saying actually is this. Say when we are applying conservation of momentum along x-axis, now this is what we write as the mathematical symbol. I hope you remember that the particle was moving initially with a velocity of mv, and after collision it is moving along the x-axis with a velocity of capital M plus small m into u cos theta. So this is our equation along x-axis. So this is equation number 1. And then we apply the conservation of momentum for y-axis. And when I consider it for y-axis, we consider it as this. Now this is symbol for just the term that we are saying here, conservation of momentum along y-axis. Now that is capital M into capital V, which is initial, and then the final is capital M plus small m and u sin theta. So now we have these two equations where we need to solve the value of u and solve the value of cos theta. So now once we write down the equations, the simplest way of solving them is squaring and adding to get u and dividing to get this value of theta. So let's see what we can do in order to solve that. So now let us take the equations. For your sake, I'll write down the equations once again. It is mv, which is capital M plus small m u cos theta, and it is capital MV, capital M plus small m u sin theta. Now you square and add. Once you square and add, what happens you see, small mv square plus capital MV square is equal to capital M plus small m square u square, and that sin square theta plus cos square theta comes within the bracket, which happens to be 1. So I hope, students, that you will be able to understand if I write down the value of u directly like this, that is mv whole square, then it is capital M capital V whole square divided, the whole divided by capital M plus small m. Why? Because this square and this root over gets nullified, and this is the value of the velocity. And as you can see from these two equations, if I divide them to get the value of theta, what I can write is capital M plus small m into u sine theta divided by capital M plus small m into u cos theta. So that gives us capital M V by small m V. And I hope students you understand that sine theta and cos theta means mix tan theta. So it is tan theta capital M V by small m V. So these are the two values we need to calculate for a 2D conservation of momentum. So I will just recapitulate what you are doing actually here. I will just tell you in short that what we are doing here actually, we are considering the momentum first along x-axis, then we are considering the momentum along y-axis, and then we are having a summation of these two momentums, and then in order to find their value, what we do is we get their resultant. And the resultant means we simply square and add. You can also understand that the concept of this px and py is this resultant, which vectorially gives us what? Gives us root over of px square plus py square. And students, I hope you get that this is exactly what we have done after writing down the equations. So this is all about momentum in 2D. Thank you, students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.